Figure skaters not only have to perform incredible feats of human strength and agility, but they also have to push the limits of what is humanly possible while making their movements look easy. Their motions appear graceful and smooth as they hurtle their bodies through the air with nothing but the hard ice below. Although skaters can make their sport look easy, executing the perfect jump requires a precise combination of speed, force, vertical velocity, angular momentum, friction, and of course, timing. So how exactly would you even consider some of these things when talking about figure skating? Well, for starters, when a skater preps for a leap, they build up angular momentum. What even is angular momentum? It is a vector quantity that is a measure of the rotational momentum of a rotating body or system. So in layman's terms, this helps drive a skater's spin and can be thought of as a spin potential. A number of factors go into that spin potential: the skater's starting position, how the position changes during takeoff, and the force that they create against the ice as they leave the surface. Once a skater leaps into the air, they're stuck with however much angular momentum they've created. So what do you do with that extra momentum? Skaters will usually transition into a spiral before their smooth ending. To execute a perfect spin, a skater must consider the moment of inertia. This determines how easy it is for an object to speed up or slow down. A larger moment of inertia, like when a skater extends their arms, will result in a slower rotational speed, but a smaller moment of inertia, like when a skater hugs their arms into their body tightly, will lead to a much faster spin. Another important role in figure skating is friction. The difference between dancing on a wooden floor and skating on ice is friction. Smooth ice provides very little resistance against objects like ice skates when being dragged across its surface. Compared to a wooden floor, ice has much less friction. What exactly is friction? It's a force that resists when two objects slide against each other, dissipating their energy or motion. When the level of friction is low, a skater is able to glide along the surface smoothly, without being stopped as soon as it has begun. At the same time, if there was no friction at all on ice, skating would be impossible, because it is the friction between the skate and the ice when a skater pushes off that starts the motion to begin with, and friction is also what allows a skater to ever come to a stop. For every action, there is an equal and opposite reaction. This was said by Isaac Newton and is referred to as his third law. This is the idea that allows skaters to move across the ice when they push off against the ice or stroke with their skates. They are applying a force down and back against the ground. Well, the ground just pushes right back, supplying a force forward and up that drives the skaters into a glide or jump, depending on the particles of the force they applied. Since the forward push is resisted only by a slight friction of the ice, the skater can glide easily. So, all in all, the next time you see a beautiful figure skater drifting across the ice and think to yourself, wow, that looks so easy, remember that it's actually quite difficult to look that graceful and there's much more physics involved than you even know.